All right, this lesson is about sound.
Yo, hey, you hear that?
Yeah, I hear it.
Yeah, I think I can see it too.
Yeah, pretty much.
But if it's just a sound,
Right.
how can it move that water?
What, you don't know about sound?
Well, I guess not.
Let me just break it down for you a little bit, okay?
Tell me all about it.
Yeah, here we go. Listen up here.
Yeah, I'm listening to your sounds.
First off, sound is a type of energy. It needs a medium to move. Now, let me see. That could be a solid, gas, or liquid. Yup, any state of matter is one sound can get with. Now, when something vibrates, it's cool. These teeny tiny particles called molecules get compressed, squeezed together real tight. And then what happens? They get rarefied or spread out, knocking other molecules around, creating a compression wave of sound. And if the sound wave hits something solid, like a window or a wall or a wallet, some of the energy gets absorbed, some transmitted through, but wait, there's more. Some energy could reflect and bounce back. That's an echo. Yo, did y'all know that? Put your hand on your throat and hum. Pick up a guitar and strum. See that? Sound is vibration, and the other way around, vibration is sound. Put your hands together and clap. What? Or put your fingers together and snap. What? Sound is vibration, and the other way around, vibration is sound. Now, how can we describe a sound? Let's start by investigating sound waves and their parts, like amplitude. That's a sound wave's height. It determines the volume. Let's get it just right. If the volume's soft, then the amplitude's short. Make it tall, it'll get loud like at a basketball court. The greater the amplitude, the louder the sound. It's the reason why we say, turn it up, turn it down. Now, the other part you need to see, the speed of the wave's vibration, the frequency. It's measured in hertz, which is a cycle per second. I'll tell you how it works. It determines the pitch, which can go all the way
Up high,
and then back down low. So if a wave's vibration is fast,
it has a high pitch and frequency.
frequency when it moves past. But if the vibration is slow,
The sound's pitch and frequency will be low.
yo, when we make sounds, waves abound. Speaking on the beat, our DJ lay down. Put your hand on a piano and play. And an organ will work the same way. Sound is vibration, and the other way around, vibration is sound. Now bang on a drum kit with a stick. Or when you whistle, feel it in your lips. Sound is vibration, and the other way around, vibration is sound.
Well, I get it now. I mean,
Right?
vibration is sound. Sound is vibration.
Yep, that's a good way to think about it.
I never thought of that before.
Well, you're welcome.
Okay.
That's right. This is the
Science
science
of
of
sound.
sound.
Sound. Sound is a form of energy. Energy is the ability to cause a change in matter. Sound is produced and transmitted by vibrating matter. The sound waves make your eardrum vibrate. Sounds are vibrations you can hear. Try this test. Put 2 fingers on your throat. Say the word ah as loud as you can. You not only hear a sound, but you can feel a movement inside your throat. When you say ah, your vocal cords vibrate. That means they move quickly back and forth. As your vocal cords vibrate, they produce sound. Sound. Sound is created when objects vibrate. Vibration means to move back and forth quickly. Let's watch a short video to see how sound vibrates. It says to turn down the volume, the video gets loud. So I will turn down my volume. So I'm going to start this again. And This is a speaker. A speaker is where sound comes out, and this is salt or sand on top of the speaker.
What is it?
368.
So as they change the sound, the pattern looks a little different.
Next.
404.
Okay, next.
452. 776.
So the higher the pitch, each frequency changes the vibration. And you can see the sound, and it moves around with the vibration.
Speak up a little more, please.
You could just say sand.
1033.
So the sound vibrates the particles and moves them with each frequency. I'm going to skip ahead. That's a very high pitch. I'm going to skip ahead again. Wow. So cool. Excellent. Sound. Sound travels in waves. Each vibration produces a sound wave, a surge of energy that travels through matter. Each wave is a disturbance moving through a medium, a solid, a liquid, or a gas. This is similar to when you throw something into a pond. It pushes the water to create little waves. The way the waves move across the water is kind of like how sound waves travel through the air. So we're going to click to see a short video to see how sound waves move. Sound moves in waves. Hold on. Hold on. Let me make it a little bigger. Okay, so this is a video to see how sound moves in waves. So you can see the strings, which is the sounds coming from the strings, and the strings vibrate and move. So you have the bigger strings go smaller or longer waves, and the smaller strings have shorter waves. Excellent. Hold on. Sound. Sound waves can be described by their wavelengths and frequencies. Wavelength is the distance between a point on one wave to the same point on the next wave. Frequency is the number of times the sound source vibrates in 1 second. The waves are all traveling at about the same speed. So this is the number of each wave that will reach the ear in 1/100th of a second. So the red one, so this musical instrument is smaller than this musical instrument. Short wavelength means lots of waves, high frequency, high sound. So if you notice here, as the wave travels, there's a lot of them, a lot of waves, wavelengths. So this instrument is bigger, and so here's your wavelength right there, sorry. Long wavelength means fewer waves, low frequency, low sound. So on this blue one, it's a longer wavelength from one bottom to the next. So it means fewer waves traveling as it gets to your ear. So it means it's going to be a lower sound. Sound. Sound can be described by its properties. Volume is how loud or soft a sound is. The waves of loud sounds have a lot of energy, and they can travel pretty far. That's why you hear the school bell even if you're not near it. The waves of softer sounds have less energy, so they usually don't travel as far.